Hi guys, this is Leela. Welcome to my channel leelawebdev. So now let's try to, in this tutorial, what we'll try to do it is, we will try to implement or otherwise copy a file without using the streams, and then we will try to implement using the streams, not NodeJS streams. We will try to implement our own streams. So that means implementing our streams. Up to now we have consumed the streams. Now we need to implement our own streams. How to implement it? So before implementing our own streams, so how we can copy a file in the Node.js without using the streams, let's try to do it. So I will try to explain you this one in this video. So that means in this one, we will learn how to copy the files. But what is the twist? We are going to do it without using the streams. So in this video, we will walk through reading and writing files in a naive way. So that means in a primitive way, we will try to see it. Running into some serious memory issues, understanding execution time versus memory usage, and wrapping it with some golden nuggets on algorithm complexity. Let's try to do it. These are all the things. So first one, what I will try to do it is, so here we are having a simple thing. So let's try to open the copy. Let's try to close these all the things. Okay, I will try to close these things. Let me close. So here I will be creating in the streams, I will be creating a new folder that is nothing but copy. Okay, in this copy folder, I will create a new file that is nothing but copy.js file. So just we need to copy one file from source file to the destination file. So for this one, what we will try to do it is, so now also, so we will either use a small text file or paste a bunch of text to make it little bigger. For now, let's keep it reasonable. So we'll try to copy let's try to take a simple file that is nothing but what we can say is in writable. So we will be having a text file, right? So now let's try to copy this one, okay, and paste it here. I'm pasting it here, test.txt file. So I have pasted it here. Let's try to close it. Let's see how much file size it is. Streams in the copy, if you try to check it, test.txt, it is around 3 MB, I am thinking so. Let's check the properties for this one. So if I try to check yeah, it is around 3 MB. So it's just a small file. I am copying this one. So let's go into this. Okay. So now let's try to write the code. So here I will be constant fs is equal to require of fs/promises. So I will be using this one, and I will be using the IAF function that is nothing but immediately invoked function async of like this, and here I will write it like this. Now let's try to implement it. So now here I will create a destination file. Destination file is equal to fs or otherwise await fs dot open of. So here I will write destination file or otherwise text-copy dot txt, and I want to open this one in a write mode. So this is a simple way how we can do it without using the streams. Now read the source file. So here I will be using constant result is equal to await fs dot read file, and in this one what I will be trying to do, so I need to copy the test.txt file, okay, which is of around 3 MB. So now here what you will be trying to, I will try to explain you this one all. So now here what we will do here, so what we would be trying to do it is, so here I will try to copy destination file. Let's try to see the console.log of results. So what would be the output for this one? Okay. So now if you try to see the console.log of result, so here we are using the read file. If you try to use the read means, then it is a different thing. It will use the, no, so if you use the fs.copy, so you can say that simply copying from this to this one, right? We can use fs.copy. So don't use that fs.copy. Why? Because that fs.copy still uses the streams behind the concept. So that's why we want to implement the concept without using the streams. So that's why I am doing this scenario. If you use fs.copy means that one behind the scenes it will use the same stream concept only. So that's why. So let's try to see what could be the output for this one. So let's go to the copy cd copy, and here I will write node copy.js file. So here the read file has given you completely 38844 something like that bytes of data. So that means the complete data is written as a buffer. So now what we need to do, so we need to write that buffer in the destination file. So that means here I can say that destination file dot write. Okay, so write, it will take the buffer. So here I can do the result. So directly buffer you can write it, and here I can use the await. That's it. So now if you try to do the code for this one, so immediately the file has been copied. So here what we have did, so first of all we have used fs.promises to work with the files asynchronously. So this is the concept. So first we open the destination file we are writing, then we read the source file using the fs.read file. Finally we write the destination to the finally we write the result to the destination file. So that is simple, and it works this one like this. So now if you run this, now here we have just once this one we have just copied the file. That's it. So now let's talk about the real world usage. So this approach reads the entire file into the memory at once. For small sizes like test.txt or something like that, this is fine. But what happens if you try to something bigger? Let's say we have a file, something like a big file which is around 10 GB or 5 GB more. So what will happen? Let's try to see it. So 5 GB or 10 GB more file we have in our let's say streams in the readable. So file hyphen huge, I think it is around 5 GB. So let's copy this one and let's go to the copy, and I will try to paste it here, file hyphen use, and it is copying. So now let's try to copy this file hyphen use which is around 5 GB. So let's try to copy this one. So go into our here, and here I want to change it to file hyphen huge.txt file. So let's try to run the code. So now if you try to run the code, boom, so we got an error. So it has crashed with an error like file size should be greater than 2 GB, and even if it doesn't crash, your RAM will suffer. Let's test the next one. So now what we need to do, it is telling that the file should not be greater than 2 GB. Okay, so fine, let's try to take it file which has an 1 GB file. Let's go to our streams, and in the writable, so we have a file which is around test-1 GB, which is around 1 GB of data. So let's try to copy this file 1 GB. So let's copy this file and go to our code, and here I want to do test-1 GB. Okay, test-1 GB.txt file. So this is the thing. So now we have updated it, and now here what I want to do it is, so rest I want to do console.time of copy, and I will try to do console.time end of copy. So I will try to keep these two things. Okay, done. So now fine, so let's try to copy this one. So now if I try to copy this one, how much time will it take? It has to cover something. Oh, it is taking so much time for me. Let's try to see it. So it took around 4 seconds to copy the file. So let's try to run it again. So if you try to run it again, let's try to see it in the activity monitor what it is happening. See, it has went to 1 GB. So the memory has went to 1 GB. If you try to see it again, the memory has been went to 1 GB. It is going. So 1 GB it is going, and that means what it is doing. So it is copying the entire file into the memory, and it is doing it. So fine. So now here, so what we have did, the problem with this approach is, okay fine, it is working, but it is using a lot of memory. It fails with the large files, and also it is not scalable. Even if it takes under 1 second or something like under 5 seconds, the space complexity is terrible. It takes about 1 second, the time complexity is less, but the space complexity is terrible. So that means it is taking too much memory. So as developers, especially in performance critical tasks, we should care about two things. One is time complexity, and another one is the space complexity. Time complexity means how fast our code runs, and space complexity means how much memory it uses. Here the time complexity is 5 seconds. Okay fine, so 1 GB file means second, that depends on your system, and the space complexity is taking is around 1 GB. So that's a linear complexity, something like big O of n in both time and space. Now if we copied a file twice as big means we need twice the RAM. This is often why we often refer to as big O of n notation. So big O of n means something like linear, big O of n square means it is quadratic. So like this, big O of log n means logarithmic. So we use this to benchmark the performance of the code, not just for interviews, but to write better, faster and learning software. So fine, so that is all about the theory. So just I want to tell you, so if you want to learn more about these algorithms and data structures, means as a developer, as a programming skills, in order to improve your programming skills, these things are must. So these algorithms and data structures, these concepts will teach you how to write efficient code, how to manage your resources better, how to analyze the trade-offs in performance. So that's it guys, what I want to explain you about this concept. Without using the streams we have did it. What is happening, it is doing more tasks, okay. So it is taking more memory, and also it is taking the space, the time complexity also. It's fine that one, but the space complexity, it was terrible. So that means what at the end of the session, what I want to release, yes, you can copy the files without streams, but it is not ideal for the larger files. Your RAM usage explodes. It crashes beyond 2 GB. If your file is about 2 GB, means it crashes. Always consider the space and time complexity also. In the next video, what we will try to do is we will try to achieve the same concept by implementing the streams on our own. We will not use the NodeJS streams. We will try to implement our streams on our own, so that we will be implementing our own streams. That's it guys. Make sure to like, subscribe and hit that bell icon so that you don't miss these all important concepts in the Node.js. Let me know in the comments, have you ever run into memory issues like this while working with the files? So drop your thoughts or questions below. See you in the next one. Happy coding. Hey everyone, welcome back. In this video, we are going to build our own mini streaming system in the Node.js, but without using the built-in stream module which is available in the Node.js. But we will manually read a file chunk by chunk, write it to another file, optimize the memory, and even handle the gigabytes of data like a pro. Let's jump right in. So normally when you read a file using fs.read file, okay, so here what you're trying to do, you are loading the entire file into memory. That's fine for small files, but something like 10 GB file means it's a disaster. You could crash your app with memory overflow. So what is the solution for this one? The solution is nothing but streams. But what if we want to build our own version of stream-like behavior? So how we can do it, this one? So let's try to do it. Let's start coding our own stream-like solution using just the file system module. First we will open a source file for reading and destination file for writing. So for this one, what I will try to do is I will comment out this code. So here in this one, I will create new one, that is nothing but async, and here this is our self-calling file. Okay, done. And now in this one, first of all, what I will try to do, I will create I will open a source file for reading and also a destination file for the writing. So let's try to open the source file is equal to await fs.open, that is nothing but let's say that the source file, right? We are having a test.txt which is a small file, and this will be open for reading, and the destination file which I will try to open fs.open. Here I can do test-copy in the write mode. That's it. So now we are using the fs promises version to keep the things async await friendly. Now let's read a chunk from the source file using the read method. So here if you want to read it means, so here constant read result is equal to await. So here we need to do the source file dot read. So this is the method, and let's try to console.log of read result. Let's try to see the read result for this one. So here I will close it and I will run node copy, and here this gives us a buffer, typically around 16 KB. It's not the whole file, just a small chunk. This is how we reduce the memory usage. So now the read method is returning you a buffer which is about 16,384, that is nothing but 16 KB. Now we need to loop over this process, read a chunk, write it to the destination, repeat until there is nothing left to read. So for this one, what we can do it, so here let's go into our code. So try to remove this one, okay, and what I will try to do, so here we got the read result. So totally we got how much? 16,384. So if you want to get the bytes read means, so here you can use something like read result dot bytes read. So if you try to see it here, that is nothing but bytes read and buffer. This is an object. Now if you try to see, the total number of bytes it has been read is the 16,384. Okay, fine. Let's go here, and what I will be trying to do it is, so I will what I would be trying to do it is so now here what I would be trying to do it is, so let's try to do something like I will take the let bytes red is equal to -1. Okay, while bytes red is not equal to 0. Okay, not equal to 0. Then what I would be trying to do, so here I would be trying to take the constant read, and I would be getting the bytes read. So here I can do bytes read is equal to read result dot bytes read. So I will copy again, and here I would be trying to do that await bytes read dot write, sorry not byte read, sorry, destination file. So I need to write in destination file dot read result dot not to string dot buffer. So the entire buffer I would be trying to write it. That's it. So now here we have written the code. So now let's go into our code, and here let's try to copy it. So it has been successfully copied. If you try to see the code here, this is the test.txt, which is 3798, but when you try to see the test-copy, it is about 3824. So the file sizes are not matching. So now, so we have written simple and efficient. We keep going, we hitting whenever the bytes read is equal to 0, which means that we have reached the end of the file. So fine. Now if I try to open this one, what is the file size difference and all those things? So let's try to open with Notepad, let's say Notepad or anything. So I will try to open this one, and here I would be trying to see at the bottom of the file. Okay, I would be trying to see at the bottom of the file. So here it is working fine. Let's try to open this one in our editor. Let's try to see what could be the issue in this one. So here this is the file which I would be trying to open, and here if I go to the bottom of this one, so here you'll be able to see a extra data, something like null is appearing here. So why it is happening here for this one? So you might be noticing weird null characters at the end of the file copy. That is because when we do the last read, the buffer might not be completely filled, meaning some of the bytes are just zeros. So for that reason, what we need to do, so let's try to console the bytes. Okay, sorry, let us console the buffer. So console.log read result dot, okay, let's try to read result it. That's it. So now if I try to copy it here, so here at the last you will be able to see all the bytes we are getting it as 0, and here also so totally we are getting 16,384 bytes, but here the buffer field is only 5,000. So that means remaining data everything is 0, and here also it is 0. So that means if the buffer is having some empty data, means it is filling with the 0. So what we need to do here, so we can get the read result dot buffer dot length. So if you try to check the buffer dot length, so here let's try to do the console.log read result dot buffer dot length. Okay, so now here read result dot buffer dot length, if you try to check it here, let's try to copy it. So here all the time you will be able to see here the 16,384, the buffer length is always 16,384. So now here let's try to write it here. So what can I do for this one in order to clear up this one? So here, so this is the entire code. Okay, fine. Now what I would be writing to do it is, so bytes read we got it. Now here let's say that here this is the thing. Okay, if bytes read is not equal to read result dot buffer length. Okay, read result dot buffer dot length, always it will be 16,384 only. So if it is not equal to this one, means so we need to get the index not filled. So index not filled is equal to index not filled. Okay, sorry, index not filled is equal to read result dot buffer not slice. We need to find the index of 0. So we need to find the 0 where it is there. So now we will try to create a new buffer. New buffer is equal to buffer dot alloc of the new, with the new memory I will be trying to create index not filled. So now here you will be having 5,882, you will get the index. I am creating a new buffer with that memory size. So now what I would be trying to do, so here I would try to copy the entire thing, read result dot buffer not equal to, so here I need to copy only part of the buffer, so dot copy of, so I try to give the new buffer and up to from where to where it will fill 0 source index and 0, and the total number what you need to fill is the index not filled. That's it. So it has been copied, and here I can do something like I will copy this entire thing and I will copy the new buffer into this one, or else part it will be something like this. That's it. So now here what we have, we only write the meaningful part of the buffer, no trailing nulls. So let's try to test it. Let's test it out. So now here I will try to run this one. So entire thing has been copied, and if you try to see the file size for this one, so here if I go here and show more options and refresh this page, so we are having test and also the test hyphen copy. So why it is not getting copied again? Bytes red is equal to this one, when bytes red is not equal to here, and read result dot buffer dot index of 0. Okay, destination file. Let's try to open this test hyphen copy and let's try to see the trailing slashes is there or not. If I try to open and if I go down to this one, okay, still trailing slashes are there. So what could be the reason for this one? If bytes is not equal to, if bytes red, so this is the only thing, right? If byte reds is not equal to read result dot buffer dot length, okay, then constant index not filled buffer dot index of 0. So here I am filling it, and read result dot buffer dot copy, and here, oh sorry, here I am need to use the new buffer. So here you should store it in the new buffer. So this new buffer I need to use it. So this is the mistake, my mistake only. Let's try to see it here. Yeah, if I try to copy and if I see the here, so it is exactly the same. The file size now it has become exactly the same. So what will happen here, the thing is, so if you try to take it anything, so something like you are having this one, right, file hyphen huge, if you try to take that one also without any problem, the file will work. So here if I try to take it as source file hyphen huge, so not a problem, not at all, it will be a problem, it will not throw any error. So it will try to read it, and if you see the activity monitor also, so it is taking around, memory is around 12, 11, 12 something like that. So the memory is also efficient. So now here when we run the script, the copy is successful and clean, no weird characters, nothing we are having. When we copy text is about something like it will take around 30 MB of memory, maximum 20 MB it is taking in our thing. So that's a huge win compared to the loading. So the traditional fs.read file method is faster but uses too much gigabytes of RAM, not scalable. Now let's we have tested with our file huge thing, which is about 5 GB. This might take us few seconds, but again memory stays at around less only, so 17, 20, maximum 20 KB it is taking. So that's a huge accomplishment. So that's it guys about this one. So it will take some time depending on the system. So my system is slow, so that's why it will take so much of time. So we have just created a custom stream like system. We don't push data into memory and then pull it out like node streams, but the concept is same. And then, so like node streams, but the concept is same. So we read a small chunk, we write it, and we repeat until it's done, all without blowing up our RAM. Of course, this is a simplified version. In production, you should wrap everything in a try-catch blocks and handle errors properly. But the takeaway here is, you don't need node streams to build something powerful. Sometimes a bit manual control goes a long way. That's it guys about this one. In the next video, we will do the same thing using the NodeJS streams and see how piping can make this even easier. So make sure to subscribe and hit the bell icon. Thanks for watching. Drop a comment if you want the full code or have any questions or something like that. Don't forget to like, share, and I will see you in the next one. Happy coding. Hey everyone, welcome back to my channel leelawebdev. In this video, we are going to take a deep dive into the NodeJS streams. Especially what we will try to do is copy files using the streams and piping. So we will walk through the concepts like flow mode, memory usage, execution time, and also what really happening behind the scenes when you use the pipe method. So let's try to understand this one. So previously we have manually read the file using data event. So using this, what I want to say is using these all the things to write the stream. So previously we have did it using the data event and all those things, right? So when you try to use the write more, I will try to open that one. So here we will be having write more. Yeah. So this one we have used using the data event, and we have did this one all. Okay. And read mode also we have used the data event and like that. So that approach works, but requires us to handle memory pressure, back pressure, pause, resume logic. It gets complex. So when you are trying to write these all the things in the readable stream or something like that, so whatever the things we are trying to do, those all the things. So here we are concentrating on the drain event, end event, and also the data event. Everything we are taking care of that one all. So everything we are approaching this. So now let's simplify all of this using the Node.js built-in pipe method. So for this built-in pipe method, so what we need to do, let's try to do it. So here we have did this copy thing, right? So this entire thing we have used our own stream without using the Node.js streams. We have implemented the streaming architecture. So instead of using that one, we will use the Node.js streams, but we will use the pipe method. So I will comment out this entire thing. Okay. And here the same thing I will try to implement it, but this time using the Node.js streams and also that too pipe method. So here I can use something like the same thing, async. Okay, I will call the self method. So that's it. So now here first of all we will create a read stream. That is nothing but what I can say is, so constant read stream is equal to, so you can create it like anything. So fs dot create read stream. Oh, we don't have an fs or what at the top. So we have an fs. Okay, it needs to have. So fine, let's try to create a source file. Constant source file is equal to, so that is nothing but what I can do it is await fs dot open, and I want to open the source file, that is nothing but test.txt. so let's say that test.txt, and I want to open it with a read mode. Same thing. So what we have did it here, where is this one? Yeah, I will try to open the source file, and also that's the destination file. Just I will try to copy and paste it here. Yeah, this is the thing I will try to do it. Fine. Now what I will try to do, so I will try to create a read stream. Constant read stream is equal to source file dot create read stream. So we have created a read stream, and constant write stream is equal to destination file dot create write stream. So now here we have created a read stream and also a write stream. So now instead of having the data event and all those things copying, so what you can do it is, you can just simply read stream dot pipe of write stream. That's it. So now you can call only with just one line, read stream dot pipe of write stream. Node handles all the heavy lifting for us: reading, writing, pausing, resuming, and also managing the back pressure. You can only call dot pipe on a readable stream. So you should call the pipe method only on a readable stream, and the destination must be writable. So this must be writable. If you accidentally try piping into a readable, it will throw an error. That is one thing. So now you can chain pipes too, but if you are doing that, the middle streams must be a duplex or transfer, because they act as both readable and writable. So here it should be, so what I can do is, so here you can have a duplex stream, something like that, dot pipe of duplex streams or something like that, you can use it. Okay, but here the middle must be act as a readable and writable. So this is something. So you can chain all the writable streams also, you can chain it. So that is what I am trying to say. So now let's try to run this one. Let's see that whether it will work fine or not. So now let's try to benchmark this one. So here I will try to do node copy.js. If you try to see, the file has been copied. If you try to see here, the test-copy and this one is one and the same only. So now let's try to do some benchmarking. Behind the scenes, the pipe listens. So we will try to use the console.time, that one. So here I can use something like here I will start stream copy. Okay, so here I will start the stream copy, and when this one is writing is completed, so when the read stream is end, then I will try to end the stream copy. Fine, let's try to run this one. So now it has taken around 40 milliseconds. Now if I try to make it as an big file, so which is a test-1 GB. Okay, source file is test-1 GB. Let's see how much time it will take. So if I try to run this one, let's see the activity manager also. So it will take some time to copy. So here if I search for the Node.js, it has taken only 6 seconds. So it has, let's try to take the node and try to run it again and see how much time it is taking, this activity manager. See, the Node.js is taking around 20 MB only. So that means the memory issue and all those things has been solved. So now it has taken only 4 seconds. If you try to see the here, so it is exactly the same bytes it is having. So we saw speeds of around 4 seconds or something, with memory usage around 20 to 30 MB, a huge improvement over the non-streamed approach. But sometimes the test timing was inaccurate. Why? Because we measured the time before. So sometimes we will be able to get it. That depends all entirely on the system. So how your system is performing, something like that. So now behind the scenes, what it will happen is that the dot pipe listens to the data, writes to the destination, and pauses or resumes the stream automatically. We can observe the stream state using the readable flowing. For example, let's say that here you can have something like readable flowing. So we will try to use this one. So readable flowing. So now here you will be having an what I mean to say is null. So now it has been started. So if I will try to do the readable flowing. So if you try to see here, now if I run this one, so here null, and also next it is a true. So that means the first time it is null. So that means the readable has not been started. So that's why it is doing readable flowing as null. When it is initially it is null, meaning the stream is idle, and after piping it switches to true, which means it is in the flowing mode. So calling unpipe detaches the writable stream and pauses the reading. So if you try to do the unpipe, so for example, let's say that here I have unpipe read, and I will try to check the what I mean to say is readable flowing. So here calling the unpipe method on the readable stream, so pauses the reading. If you repipe again, it resumes. So if you try to check it here, the output for this one, so here it has been unpiped, false. So now if you want to start it again, so you can use this one again. So here, and again you can console.log of this one, so that it again turns to true. So this is the thing which I would be trying to do it. So first one will be in the null state. Okay. So then I am starting the thing. It will be in the true state. Why? Because it will be in the readable flowing. And again I have unpiped it. It will be in the false. And the last again I have resumed it. So it will be in the true. So this is how it will be happening. So if you try to see the same thing. So null, true, false and true. So null, true, false and true. So the same thing has been happened. So that is the main thing. So these events are you. So here what I can say it is, so now, so you will often use the end to trigger the cleanup. So production consideration. One drawback of pipe in production is error handling. Errors on either stream won't be propagated unless you listen for them explicitly. So that means, so you need to listen for the read stream dot on off error and write stream dot on off error. So we need to write it and we need to handle the error manually. So you must manually destroy the both streams to avoid the memory leaks. So that is also one thing which you need to understand. So that's it guys about the stream piping concept, which I would try to explain you. So to recap, pipe simplifies the file copying, automatically handles the pause, resume and back pressure, chains with the transform and duplex streams, readable flowing shows the stream state, use events like pipe, unpipe and like that. In production, handle errors manually. We should handle the errors manually. So now I hope that you have a solid understanding of piping with the Node.js streams. If you enjoyed this breakdown, hit that like button, subscribe and leave a comment. And if you have got any questions or want more deep dives like this. Thanks for watching. I will see you in the next video. Hey folks, welcome back to my channel Leela WebDev. Today we are diving into the Node.js streams and discussing why you should stop using the pipe in production. So why we should not use the usage of this pipe in production, we'll try to see, and instead switching to something new better than the pipe is pipeline. So we also look into an older tool which is called pump, how errors are handled in the streams, and finally how to create your own custom streams like writable, readable, duplex and transform. These are all the things we'll try to do it. So let's see about this one. So if you have ever used streams in Node.js, you have probably seen this pattern. So like let's try to see this one. So yeah, here. So if I try to remove this entire thing, okay. So normally if you are trying to see this one, so normally what you will try to do, you will try to open these things. You will create a read stream and also you will create a write stream, and you will try to do read stream.pipe of write stream, so that the read stream, whatever the data is there, it will be written, copied into the write stream. So fine, this is fine for basic use, but here is the problem. What happens if an error occur in any one of these streams? So if any error occurs in the read stream or write stream, something happens is, then what we will try to do? So .pipe does not handle errors or cleanup streams automatically. So it will not do the handling the errors or cleaning up the streams automatically. It will not do it. If write stream emits an error or gets closed, read stream just keeps on going, wasting memory and potentially leading to leaks. So that's the thing. So here is the better way. Node.js introduced a new one, that is nothing but a pipeline method. So let's try to see about this one. Let's go to the docs, and here in our let's say in our streams, so you will be having about the pipeline. Okay, so pipeline, yeah, here. So pipeline, if I try to click on this pipeline, so here you'll be able to see, so the pipeline, and here you'll be able to have a source, destination, and options also you'll be able to pass it. So now here signal argument, and it has been history, it has been added in 15.0.0. okay, so now here pipeline API, you will be able to see stream.finish. So this is the pipeline. So pipeline, if you try to check it, also supports async, signal, and here the pipeline is there, pipeline streams callback. So this is the pipeline. So normally, so a module method to pipe between the streams and generators, forwarding the errors and properly cleaning up, and provide a callback when the pipeline is completed. So this is this method. It is used to pipe between the stream and generators, forwarding the errors. It will forward the errors and properly clean up. It cleans up, and also provide a callback when the pipeline is completed. So that is the thing. So it has been introduced in something around added in 10 version. So like this, it has been added, going on added, supported for web streams also. So this method does the same thing as pipe, but it has a built-in error handling and also a cleanup. So for writing this code, so what you need to do here, the same code which you are trying to write it, the same code. So we need to constant. So here you need to get it, pipeline is equal to require of streams. Okay, stream. So you need to get the stream or stream, I think, I don't know, I remember exactly. So stream, fine. So now you have created write stream, and also you have created the read stream, right? So instead of using this one, so what you need to do it is, instead of using this one, so what you need to do is, so here we have used this end and all those things, right? So instead of using this one, so here you can use the pipeline of, so here you will be having a first one is the read stream, okay, and the next one you will be having is the write stream. So the next one will be a error handling, okay. So this is our error handling. If error is there means, then you can console.error pipeline, pipeline failed, and here you can write comma error, you can mention the error. Else means you can do console.log pipeline success or succeeded, something like that. So as you can see, we pass all our streams into a pipeline, whatever the streams are there. So in between this one, if you are trying to use it, it should be a duplex or a transform stream. At the end you should have a write stream. So in between, if you add a write stream, so this data will be copied into this write stream, and this write stream does not send any data, so this write stream will not be worked. So as you can see, we pass all our streams into a pipeline, and it automatically wires up all the pipe logic, plus add cleans up if any streams fail. This is a must for production. If a stream crashes like due to network hiccup or something like that, it cleans up and prevents the memory leaks. So that is main thing. So key point is automatic cleanup, error forwarding and cleaner callback. So that is the main thing. So normally before we don't have this pipeline, so what we have used it is, we have used something as a pump. So pump is an npm package. So if you try to click here, pump, it has been developed 5 years ago, I think. So let's try to see it. It has been published 7 months back. Okay, so this pump is a module. Yeah, so here this is a small module that pipe streams together and destroys all of them in one of them if one of them closes. So here this is same thing only. Instead of using the pipeline, we will be using the pump, source and destination, and here you will be having an error. That's it. So now here when destination is closed, pump will destroy source. So this is how you will be able to have it. So before using this one, so we had to rely on a package called pump to handle this one. So the same thing, the pump also does the same thing only. Pump made things safer than pipe, and it is still used today. In fact, it has over if you are able to see 36 million downloads or something like that, you are having it. So 40 something around it you are having. So it is having so many downloads. This one weekly downloads you are having it. Fine. So now quick recap. What I want to do it is, so if you are using with the pipe, automatic error handling will not be there, automatic cleanup will not be there, but the native support will be there. Whereas for the pump, automatic error handling will be there, automatic cleanup will be there, and native support will not be there. Whereas for the pipeline, automatic error handling is applied, and also automatic cleanup is also there, and also there is a native support in the Node.js. So there is one thing which I want to tell you. Another useful tool before closing I want to discuss with you is, that is nothing but finished. So we have seen it at the bottom only. We have seen one finished. I will try to show you finished. Stream.finished. So this one is also one of the important thing. So where is stream.finished? So now what does this one do? Stream.finished function from the stream module. It comes from the stream module. It tells you when a stream has been finished reading or writing or had an error. So that is the main thing. So that means you can use create read stream. So for this one, so here you need to provide readable stream or writable stream, anything. So when the stream is finished, it will tell you when it has been finished. So whatever the things you want to do it, you can do it. So here you can use something like this. So here you can use this one, and you can use the read stream, and here it will tell you, and this should be imported from the finished, and this should be imported from the stream. So here you can able to see finished. Yeah, so this is also one concept. So it will tell you when the stream has been finished. This can be useful if you are working with individual streams and want to manage cleanup manually. So that is the main thing. So now that is all about the thing. So this is all about the pipeline concept which I want to tell you. So next we will try to create our own writable streams. How we can create our own stream, that too writable stream, we'll try to see it. So to wrap up things up, so what we have learned in this one is, we have used the pipeline instead of the pipe. For old versions we will be using the pump package. So the finished thing also we have learned it. So when for stream lifecycle management, so whenever the stream has an error or it has been finished, means if you want to do cleanup manually, means we can use this finished method. And we have avoided the memory leaks by cleaning up the streams. Understand when to use the writable, readable duplex streams. So that one all coming next, we will try to do it. So if you like this deep dive, hit the like button and don't forget to subscribe so you don't miss the next episode where we implement custom streams from the scratch. Thanks for watching, and as always, keep building awesome stuff. See you in the next video. Thank you.